What are you reading then? There's barely any letters to read, yet you add some extra letters based on past experiences to make sense of this sentence, to make sense of this world, to redefine normalcy. When you look at something, what you're really seeing is the light that bounced off it and entered your eye into the retina that covers the back of your eyeball. In the retina, there are two types of light detecting cells, rods and cones. Rods are used to see in low light condition, but with cones there are three types, each corresponding to a different color, red, green and blue. When you see a color, each cone sends a distinct electrical signal to your brain where it is then turned into an image that you can use. This process takes about 1/10 of a second, but your eyes receive a constant stream of light, an incredible amount of information, so it's really difficult for your brain to try to focus on everything at once. Your brain hence takes shortcuts, simplifying what you see to help you concentrate on what's important, which helps compensate for your brain's 1/10 of a second processing lag. More appropriately known as visual illusions, involves visual deception. Due to arrangement of images, the effect of colors, the impact of light source or other variables, a wide range of misleading visual effects can be seen. The information gathered by the eye is processed by the brain, creating a perception that in reality does not match the true image. Important to note, we don't always see what's really there. Our perceptions depend upon how our visual system responds to environmental stimuli and how our brain then interprets this information. Stare at the blue and white strips for a few seconds, and most likely you will see a yellow halo in your visual field. Yet there is no yellow in this. This effect is known as simultaneous contrast, a principle that the perception of a color is dependent on what other colors surround it. Bright colors cast a shadow of their complementary color. For example, blue contrasts yellow, which is why the area surrounding the blue square takes on a golden hue. In 1957, Donald Mackay discovered that radiating lines create a glimmer of movement. This effect can be explained by the involuntary rapid eye movements called microsaccades. When presented with heavily patterned, high-contrast images, the eye can't focus its attention, bringing the picture in and out of focus, appearing to be in motion. Quite similar to the image I created 2 weeks ago without even understanding this phenomena. This right here is a case of linear perspective, a phenomenon of optics that light travels in a straight line. Around 1415, the Renaissance architect Filippo Brunelleschi is thought to have invented linear perspective, the first mathematical method for tricking the human eye. It involved arranging a composition around a vantage point that appeared to recede into the distance. A lot of artists since have used this phenomenon to manipulate the colors and shapes of abstract forms, creating images that appear to balloon out into space. During the 1960s, op art, short for optical art, combined the two disciplines of neuroscience and art by challenging the role of illusion in art. Ever since, not only have optical illusions been restricted to 2D art, it is now used by multiple artists and designers to enable visitors to see beyond reality, a sort of philosophy. Anamorphism has been heavily used by multiple artists. It involves using a distorted projection or perspective, especially an image distorted in such a way that it becomes visible only when viewed in a special manner. Ames' room is another form of spatial optical illusion. When viewed with one eye through a peephole, the room appears to be ordinary rectangular cuboid with a back wall that is vertical and at right angles to an observer's line of sight, two vertical side walls parallel to each other, and a horizontal floor and ceiling. The true shape of the room, however, is that of a six-sided convex polyhedron. Depending on the design of the room, all surfaces can be regular or irregular quadrilaterals, so that one corner of the room is far from an observer than the other. Optical illusions can be used in a far more intangible and emotional manner, allowing visitors to just be and feel something that isn't actually real. Olafur Eliasson's weather project employed a semicircular screen, a ceiling of mirrors, and an artificial mist to create the illusion of the sun, to create an image of a massive indoor sunset seen through the artificial mist emitted into the room. By understanding illusions, we understand that the human visual system is not a mirror for the outside world. It is rather capable of seeing far beyond what is actually there, far beyond reality.